This recording is with regards to Unit 4, the binomial distribution. The binomial distribution is used to model situations where there are just two possible outcomes, success and failure. What does this mean? Well, here we are going to do an introduction to the binomial distribution. Let's presume an experiment is any activity chiefly composed with trials, where every trial has a certain number of outcomes, a result of. For example, tossing a six-sided unbiased dice 5 times can be considered an experiment. Each toss is a trial which contains 6 possible outcomes. With every toss, each outcome is likely to happen. The outcomes obtaining 1, 2, 3, 4, or 6, 5 or 6. Each outcome has a probability of occurrence. Because the dice is unbiased, each outcome is equally likely to occur. So that's an example of an experiment. We also need to have clear in mind the definition of what is a random variable. We have an idea what is a variable, which is the characteristic of an object that you are studying. But what is a random variable? It's a numerical description of the outcome of an experiment. Okay, this quantity is not fixed and has a minimum value of 0 and a maximum value of the total number of trials. This random variable must be defined and is normally given the letter X, capital X. Okay, so it's a variable whose value depends on chance. Okay. For example, in the above experiment, an example of a random variable is X equal to the number of 6s obtained out of the 5 tosses. So that would be a discrete random variable. The number of 6s obtained. Okay. Now it is obvious that with each toss, you can obtain a 6 or not obtain a 6. Okay, so you can succeed in obtaining a 6 or you can fail in obtaining a 6. So general definition of the random variable for a binomial distribution, X is equal to the number of 5s obtained out of the 5 trials. For example, that's another random variable, the number of 5s obtained. So with each toss, you can either get a 5 or not get a 5, success or failure. So two possible outcomes with every toss or trial, either you obtain a 6 or you do not obtain a 6. So that's just repetition, what we have just said. If after you toss you obtain a 6, then you have succeeded. If after you toss, you obtain a 3, then you have failed in obtaining a 6, yes? Because remember, your random variable was defined to be the number of 6s obtained, okay? The two possible outcomes in a binomial distribution are successes S and failure F. Now bear in mind, we said that the discrete random variable here can have values or assume values from 0 to the number of trials. So for example, you can toss the coin 5 times and never get a 6. So that means there's a probability of your random variable being 0, meaning not getting a 6 at all. Being 1, being getting a 6 only once. Being 2, getting a 6 twice. Okay? And the maximum number of 6s you can get is equal to 5 because it's 5 times tried. So that's what is meant by this quantity is not fixed and has a minimum value of 0 and a maximum value of the total number of trials. Okay? So the number of 6s obtained can be 0, 1, 2, 3, 4, or 5. Now, let's talk about the probability of success. Given the lowercase letter p, it must be constant with every trial. It must be the same throughout the experiment. It automatically follows that the probability of failure, which is q, given the letter q is equal to 1 minus p, will also be constant. The total number of trials n must also be a well-defined and fixed number, whole number. It's important to note that every trial must be independent of each other. So these are very much important conditions for the binomial distribution. So let's talk about the binomial distribution notation. The random variable is given by x is equal to the number of dash obtained out of the dash trials, okay? number of successes obtained out of the 5 trials, for example. So that's a general outline of defining your random variable for binomial distribution. The probability of obtaining one of that random variable with each independent trial is equal to P. It must be constant. So to describe the random variable, you write X, which is the letter that you use to denote that definition of the random variable. Okay, so anytime you see X in your analysis, you should see the number of whatever. Approximates a binomial, B for binomial, and the parameters that I use is the number of trials and the probability of success, N and P. So the above reads, the random variable X follows a random binomial distribution with N number of trials and probability of success, P. So that's how you read this notation. Now you will be answering the question, what is the probability of obtaining dash of the random variable out of the N trials? So that will be a prominent question in the exercises and examples following. So the blank space will be represented by the letter R in the following formula. So the probability that your random variable is equal to a certain value R is equal to N combination R. Okay. Probability of success raised to the R times 1 minus P raised to the N minus R. So this is the formula to calculate probabilities for a binomial distribution. The above formula reads, the probability that out of the N trials, the number of X's obtained is R is equal to N combination R times P raised to the R times 1 minus P raised to the N minus R. So the mean or the population mean or the expected value E of X of the random variable in a binomial distribution can be calculated by the following formula. So mu now is the population mean symbol, we know that already, and it's also given the notation E of X. So E of X is another notation for population mean, and it's basically calculated by multiplying the number of trials times the probability of success, N times P. And variance, the population variance, sigma squared of the random variable in the binomial distribution can be calculated by the following formula. Variance, which is given the symbol sigma squared, is equal to NP times 1 minus P, or NPQ, because Q is equal to 1 minus P. And here we have an example of a situation of a random variable, a scenario whereby you have a 4-sided dice is thrown 5 times. So if X denotes the number of 3s obtained, describe the distribution of X and find the probability that X is equal to 2, meaning the number of 3s obtained out of the 5 trials is 2. So you get 2 3s. What's the probability of getting 2 3s out of the 5 trials? So X has a binomial distribution with N is equal to 5 and P is equal to a quarter. Okay, so because it's a 4-sided dice. So the random variable, the number of 3s obtained, approximate a binomial distribution if 5, N is equal to 5 trials, and a probability of success 1 over 4. So the probability that your random variable is equal to 2, that you get 2 3s, is equal to 5 combination 2, a quarter raised to the 2, and 3/4 raised to the 3, because 1 minus a quarter is 3/4, and 5 minus 2 is 3. And that will give us 0.263. 7 to 4 significant figures. And the discrete probability distribution can be constructed by actually calculating probabilities of each value that is possible for that random variable. So it's possible not to get any 3s. It's possible to get 1 3. It's possible to get 2 3s, 3 3s, 4 3s, 5 3s. That's the maximum number of 3s you can obtain because 5 times you are tossing the dice. And as you can see, the probability of each of these values have been calculated. And if you add these values, you're supposed to get 1. Okay, so the probability of getting 3 3s is 0.08789. The probability of getting 5 3s is 0.00098. Okay, the probability of not getting a 3 at all is 0.2373.